Salam and hi everyone. Welcome to our group presentation, Group 3, Wireless Communication EDI 4503. Today we will be talking about the advancements in 7th generation wireless communication. Over the years, wireless communication has improved from basic voice calls in one generation to the high-speed internet of 5th generation and the smarter systems of 6th generation. Now, 7th generation is being developed to take things even further. Seventh generation aims to connect everyone, everywhere, using satellites, AI, and powerful new signals like terahertz wave. It promises super fast speeds, very low delay, and full global coverage, even in remote or space areas. In this presentation, we will explore what researchers have discovered about 7th generation, the challenges we still face, and how this next generation of wireless technology could change the way we live and communicate. Okay, starting with the first article, 5th generation versus 6th generation versus 7th generation, unveiling the future of connectivity. This article highlights how the demand for faster, more reliable, and smarter communication is growing every day. As we move from 5th generation to 6th generation and eventually 7th generation, the study explains the technical challenges we face, such as upgrading infrastructure, improving data security, reducing energy usage, and supporting new technologies like IoT, AI, and virtual reality. The researchers used a comparative method by reviewing past studies, expert interviews, and statistical analysis. They compared speed, latency, bandwidth, and energy efficiency across the three generations. Some key findings include 7th generation is expected to provide ultra high speed up to 100 Gbps, almost zero latency, and global coverage by combining both satellite and ground networks. AI will play a big role in managing traffic, fixing network issues, and improving overall performance. This means more reliable communication even in remote areas. The article also recommends using AI to manage network traffic and detect problems in real time. It suggests applying edge computing to reduce delay and improve energy use, and strengthening security through AI-powered protection systems. Now moving to second article, a comprehensive overview of 7th generation wireless communication technologies. This article looks more closely at what 7th generation might offer in the future. Some possible applications include crime control, health monitoring, threat detection, and even mind reading, though these are still just concepts for now. The main problem discussed is that even though 7th generation promises ultra-fast speed, high capacity, and low latency, we still face major challenges. These include managing spectrum use, interference, high energy consumption, and the need for clear regulations and ethical guidelines. The findings show that 7th generation can greatly improve communication in terms of speed, real-time response, large device support, and stronger security. It will support future technology like telemedicine, autonomous vehicle, and smart cities. The article recommends continuing research on 7th generation core technologies, planning for ethical and legal issues early, focusing on key uses like healthcare and mobility, and making sure 7th generation stay affordable and widely available.
We navigate the further of 7th generation mobile wireless network. 7th generation will revolutionize mobile network by combining satellite and terrestrial system to deliver ultra-fast globally available connectivity without the zones. This next generation technology promise, promises seamless space roaming for uninterpreted service anywhere on Earth while supporting advanced GPS and real-time data services. Achieving the Achieving this requires global standard and solution to challenges like latency and cost. While implemented, 7G could enable transformative technologies from smart cities to space communication, creating a truly borderless digital world. For literature review on wireless technology from 0G to 7G. This review of 14 source chronicles wireless technologies evolution from 0G to 7G, showing how each generation advanced from basic voice 1G to SMS 2G, mobile data 3G, broadband 4G, millimeter wave 5G, and satellite integration 6G with 7G, aiming for global coverage through combined spectrum network. Finding emphasized to the need for higher data rates, continuous R&D to overcome current limits, and global standard for seamless satellite cellular integration as achieving through worldwide connectivity would transform communication by removing geographic restriction and enabling universal real-time access regardless of location.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azrul bin Arasli, and my metric number is X8229, and then I will be discuss about Article 5, the wireless communication and application above 100 GHz, opportunities and challenge for 6G and beyond. For problem statement, the demand for faster internet is pushing the use of the very high frequency, which is above 100 GHz, but this signal lose strength quickly, use more power, and need complete internet. It's still hard to understand how this signal behave, and aiming them properly is also a big challenge. There are no clear rules or standard yet, so we need new idea and technology to solve this problem for future 6G network. Okay, for research methodology, research use special tools like VNA and THZ to TDS to test how signal behave above 100 GHz in both clear and blocked parts, and they apply signal processing method like waveforming and compare different frequency, which is 28, 73 and 142 GHz. For simulation and formula had confirm the result, making the study reliable and useful for future system. And then the finding, the study found better way to save power and direct signal at high frequency. New model for signal loss and position tracking were developed. The results show that THZ signal can work for future communication and suggest way improve energy use and performance in 6G system for 2025 to 2035. So the recommendation, more research is need to check if THZ signals are safe for human and animal. THZ will also be a better and safe option than X-ray for future imaging and medical use. And for Article 6, issue, challenge and research trend in spectrum management, a comprehensive overview and new vision for design 6G networks. For problem statement, as 5G continues to roll out, its limitation like spectrum suggestion, latency, and data capacity are becoming more apparent. This has led to global research into 6G network, which aim to overcome this challenge using advanced method uses such as carrier aggregation, cognitive radio, and then wave, and then massive MIMO and tiny cell based head nets. However, the integrating all this technology raise serious spectrum management issue that need to be addressed. So for the research methodology, the research involves theoretical study, prototype testing, and technology tried in controlled environment. It defines 6G requirement like ultra low latency, energy efficiency, and ability. And then technology like AI driven network control, massive MIMO, and terahertz communication are tested to evaluate the performance and read lines. And then for findings, 5G is expected to deliver ultra fast connectivity, which is 2 terabits per second, and ultra low latency, which is microsecond, enabling advanced applications such as seamless AR or VR and real-time gaming, autonomous vehicle, and remote surgeries. AI will drive automation in smart city and industry, supported by millions of sensors and next-gen code or for system. For recommendation, support digital inclusion, develop policies to ensure equal access to 6G, especially in rural or underserved area, and then encourage global collaboration, which is a standardization body like ITU2R and 3GPP should align stakeholders to ensure global 6G adoption. And lastly, ensure security and privacy, design network with strong encryption, instruction detection, and user.
Okay, next I will begin by presenting Article 7. It's titled Insight into the Development Trend in 7G Mobile Wireless Network. This article discusses how 7G technology is expected to revolutionize global connectivity, especially by integrating space roaming and seamless satellite communication. And for problem statement, the main issue identified are lack of standardized protocol for satellite to mobile communication. Second, difficulty in managing signal during international roaming. And last, high cost of making the technology affordable for all users worldwide. And research methodology. The article analyzed the evolution of wireless generation from 0G to 6G. It used trend analysis and theoretical projection to forecast what 7G might offer, focus on ultra-low latency, AI core networking, nano antenna, and satellite integration. It also considered challenges such as spectrum availability and legacy system integration. For finding, some important findings include is wireless generation has increased speed, bandwidth, and capability. And 7G is expected to support spatial roaming, HD video broadcasting, and global high-speed internet via satellite. And achieving this will require new communication standard and advanced hardware such as nano antenna. And recommendation to make 7G a reality, the article recommend developing unified protocol for integrating satellite and terrestrial network. Second, encouraging global collaboration to share spectrum and reduce development costs. Last, accelerating research in AI, nano antenna, and high-speed system to support smart city, healthcare, and transport. Okay, now I'm moving to Article 8. Seamless convergence between terahertz radio and optical fiber communication towards 7G system, which focus on the technical integration of terahertz radio with optical fiber communication, an essential step toward achieving high-speed 7G network. For problem statement, integrating terahertz and optical fiber face major technical challenges. First, high frequency signal loss. Second, limited power and poor receiver sensitivity. And last, highlight development costs for dense base station. To overcome this, robust radio over fiber system and hybrid analog digital design are essential. And research methodology, the study review current technology like roof system, photonic techniques for smooth signal conversion. It also explore advanced solutions such as intensity modulation and right detection, optical frequency optoelectronic oscillator. This method helps solve issues like bass noise and dissipation. For finding, key discoveries include thin film, lithium niobate modulator, and UTC photodiodes can generate signal over 100 Hz. Optical frequency can provide stable and tunable terahertz generation. Environment factors like wind and rain affect signal reliability and must be managed, especially in fixed wireless system. And last recommendation, the article suggests developing low latency, energy efficiency roof system, and improving performance with optical modulation technology like IMDD and Delta Sigma, and promoting global collaboration for standardization and performance reliability. And last, designing robust antenna and infrastructure to handle environment impacts. That's all from me. Thank you.
Assalamualaikum. For Article 9, the future of 7G communication unlocking new horizons. Problem statement: global connectivity ensuring coverage in rural, oceanic, and deep space areas via satellite, terrestrial integration, security reason need for data protection using quorum encryption, research methodology, literature review, analyzation, 5G or 6G, AI satellite system, quantum touch. The third is key finding. Satellite network crucial for global coverage. Quantum communication essential for secure 7G encryption. The lastly is recommendation. AI-driven network for autonomous, scalable, and resilient system. Suitable solution involves in green technologies and smart power use. The title 10 is atmospheric propagation of sub-THz wave and 6G and 7G communication. Problem statement: high frequency negative 700 GHz phase severe atmospheric attenuation due to moisture absorption. Cost: reduced range, increased receiver noise, and limited user access. Research methodology: review potential application of sub-frequency. Key finding: server signal loss, limit range of 7G at high frequency. Recommendation: use a mix of sub and sub-6 frequencies. Address inference, improve spectrum efficiency, and develop new coding and security tech.
And the last part, conclusion. 7th generation is not just about faster speed, it's about connecting everyone everywhere. By combining satellite and ground network with smart technology like AI and advanced signal, it promises safer, smoother, and more reliable communication. Challenges like cost and complexity remain, but steady progress show we are getting closer to a future where our connection is truly universal. That's all from our group. Thank you.